Okay, we are now ready to start into our last unit of college math, which is statistics. Now, what we're going to look at is an overview of statistics. It will provide a background for any of you who need to take a full statistics course and get you maybe through the first 1 to 2 weeks of a course and get you ready up and going. What this will allow you to do is that you'll be starting just a little bit ahead of people who've never taken a statistics course or covered it. So it's just enough to get you going, enough to get you understanding, and enough information so that you don't become duped by the media, which sometimes can take statistics and present it in a way, as we'll see tonight, that might be a little bit misleading, or sometimes more than just a little bit misleading. Okay, so let's start here with this. So chapter 12, statistics. Let's just get started. So first of all, I've revised the schedule a little bit. So we're going to jump into just 12.1 tonight. Instead, we were going to do 12.1 and 2, but what I've done is it'll be better if we do 2 and 3 together, followed by 4 and 5 together. This 4 and 5 is on the normal curve, which, the bell-shaped curve, which is what a lot of people think about when they hear about statistics. So that we'll do that all in one night. And 2 and 3 are central tendency, which like mean, median, mode, the average, which you're probably used to, and something called the standard deviation, or how spread out the data is. So those are two calculation things that go together real well. And tonight is going to be a lot about vocabulary of statistics. So there will be a little bit of mathematics. It's mostly how to display some of the descriptive statistics that we're going to take a look at, but mostly it will be about vocabulary. So here we go. We're going to talk about sampling, about frequency, how often something happens. Distributions is sort of how things are spread out, and then graphs. And we're good to go. So again, we'll talk about these words, what it means for a population. It is a group of people or things, but it's statistics. It's got a very specific meaning. We'll look about what sampling is and appropriate techniques, how to organize and present data. And then, like I said, we're going to look at some ways that graphs can be done in a deceptive way to make you think something that isn't really true. Okay, so first of all, these definitions. What is statistics? Well, statistics actually has two different meanings. It is a method that's used for collecting, organizing, analyzing, and interpreting data, but it's also the conclusions based on the data itself. So sometimes the statistics we refer to as the data, and then other times we're talking about statistics as sort of the science of dealing with data. So a statistics course is a science, teaches you the science of dealing with data. But again, we will also, in natural everyday English, refer to data itself sometimes as the statistics. Okay, so we have descriptive statistics. What are descriptive statistics? They are ways of presenting data, collecting it and organizing it will be the primary ways. So we get this bunch of data. It's hard to understand what's going on. We organize it so it's going to be meaningful. And then the other type of statistics that we deal with are what's called inferential statistics, which allow us to make maybe either predictions or generalizations about a population, about a situation. So drawing conclusions, making generalizations, we're able to tell something from those data. The descriptive, we are able to tell what the group looks like, right? Okay, so let's get down more definitions. What is a population? It's simply a set of people, place, objects, things that all have a similar property. Okay, so when you're collecting the data, you're collecting it on a population. Now, a population could be very specific. Mrs. Smith's fifth grade classroom. That might be your population for. Well, it might be Mrs. Smith's population for a study she's doing on her class. That's her population. However, we're going to see that that might be just a small part of a population if we talk about all fifth graders in a particular city or country or world. So, how we define our population is important for the study. The sample is a group from within the population. So the population is always the larger group of everybody we're possibly might be talking about in our study. The sample is generally a smaller group that we actually do the study on or we get the information about. So it is a subgroup, generally smaller. There are studies where, like Mrs. Smith, she could study her whole class, so she's studying her population, but those are not really very, I won't say popular, but those are generally not the way studies are done. A study is done on a larger population. We go look at a sample, and then we make some inferences or some predictions about how it applies to the larger group. So a representative sample, this is important. It's a sample. You can't just take any sample. You've got to get a sample that represents that whole population. And so we need the sample to be diverse, just to the same level that our group, our population is diverse. So they have to possess the same things as the target population. Now, if our population is all fifth graders, then our sample should be all fifth graders. However, if our population is a grade school from first to sixth, we should have a representative number of people of students in our sample that come from each of the grades. Make sense? Okay, I'm going to ask you some questions as we go here. I know we're video and we're taped, but I want you to think about it and go ahead, talk to your computer, give it back to me, give me the answer, and we'll see how we do. So, a few of these. Okay, so population set. A group of hotel owners in a large city decided to conduct a survey among citizens of the city to discover their opinions about casino gambling. So let's describe the population. They already did it for us. Population is a set of all the citizens of the city, right? Because they want to get a survey among the citizens of the city. This is the population right here, because they want to discover what everybody's opinion is about casino gambling. Not just the gamblers, not just the ones who hate gambling, everybody. Okay, so the population is all of the citizens. Okay, so with that in mind, this is supposed to we'll keep going. I thought I had these coming out a little bit at a time. So population samples. So one of the hotel owners suggests obtaining a sample by surveying all the people at 6 of the largest nightclubs in the city on a Saturday night. Each person will be asked to express his or her opinion. Does this seem like a good idea? Well, will we get everybody? Well, we get the people who go hang out at nightclubs on Saturday night, right? Questioning people at 6 of the city's largest nightclubs, it's a terrible idea. They don't even mince words here, right? The nightclub subset is probably more likely to have a positive attitude toward casino gambling than the population of all the city's citizens. And notice who suggested it? The hotel owners. Hotel owners probably want that casino because it's going to bring more tourism, fill their rooms. So they're kind of wanting to have the data skew, we'll learn about that later, have it skewed towards the casino gambler favorable idea people, whatever that means. Okay. Here we go. I've got this part of the thing, the PowerPoint set up. So what's a random sample? It's a sample that's obtained in such a way that everybody in the population has an equal chance of being selected. So, and it's randomly generated. So this is how we go about this. First, we have to identify each of the people in the population. Now, if we want everybody in the city, we have to make sure we're able to get everybody, right? And a lot of times, studies will overlook, uh, you know, college students. They might not be considered because you might be away at college, but you're actually a city resident, aren't you? It could overlook homeless people. It could overlook uh, people staying in hotels, right? Because who might be long term. There could be a lot of different ways, but what you've got to do if you want to get a full population, you have to see who's all in that population. One method then is you assign them a number of some sort, and then you randomly select numbers so that the number and the person are matched. And then of the numbers that are chosen, those are the people who will be asked to be in the sample. Those are the ones that'll be surveyed. Now, again, with research, you'll see that because of protection of human subjects, not everybody who was chosen to be in the sample needs to participate. They have their freedom to say, no, I don't want to be part of your study. So oftentimes you'll do this, they'll do a random sample if they need, say, 500 responses. They'll shoot for 750 or 1,000 because some people may not want to do it and other reasons. Okay, so now we're going to look if about getting this random sample for the people to see who favors casinos versus not favoring casinos, the city citizen, how should we go about it? So randomly survey people who live in the oceanfront condominiums in the city. What do you think? Is that going to get everybody? Well, that's back to the hotel people. Many hotels lie along the oceanfront. These people might object to the increased traffic. Well, that's true, but they also might like the hotels. They might not like the increased traffic and noise, which may result. It also does not give each citizen of the city. This is my bigger thing is well, yeah, they may have a bias, but the most important thing is we're not going to get a representative because not everybody has an equal chance. We're just going to one region. That's really the big thing. How about another one? We'll survey the first 200 people whose names appear in the city's phone directory. Well, what do you think? Just take it from the beginning, right? Well, people with names that start with Z or maybe even M, they don't even have a chance, do they? Only the first part of the alphabet does. And so again, does not give each citizen of the city equal chance to be chosen. Now, if you randomly went through a phone book, that might be it. But then again, how many people are listed in the phone book these days? This is probably an older, yeah, if you see back as far as 2011. I don't even have a phone book. Any of you guys have phone books? I don't know. I didn't know those things still exist. But anyway, a number of people might not be in that phone book. Randomly select neighborhoods of the city and then randomly survey people within the selected neighborhoods. Okay, so this will scatter it around if you do it truly randomly. This is called, like, if you go into a full statistics course, this would be like a cluster sample. You don't need to know all that, but the fact that everybody has an opportunity, right? Here it is. Yeah, gives each citizen of the city an equal chance. That's random sampling. Okay. So now we're going to get into some descriptive statistics and organizing. So one way we can organize data, because here's some data. Age of maximum yearly growth for 35 boys. So what year that they had their maximum growth spurt. And we have just a bunch of ages. And you can see it's kind of hard to figure out what's going on here, which one's most, which one's less. So what we want to do is make a frequency distribution. So maximum age of growth and number of boys. We'll in a moment, we will actually make one of these off of some data. So, but what they've done is they've organized, so they went through and counted all how many there are that have 10, and there was only one. 11 had 2. Okay, so they went through and picked them out and tallied them up, and this is what we get. So what are some, just looking at that data, what are some things that you can say? There's ones here, there's one, where is the most part of our data? So let's go to the next one. What are some of the conclusions from this example? Well, the conclusions we could draw, we can see right here at 14, it's the highest, right, 9, and then it goes down, it goes up till then, and sort of right here in the middle is the most. Where's the cutoff? I don't know, maybe 12 to 15 or 16, maybe 12 to 15. Maximum growth for most subjects occurred between 12 and 15. Yeah, you might go to 16. I don't know. There's no hard fast rule, but yes, most of the growth occurs right here in the middle. And then the number of boys who attain their maximum yearly growth at a given age increases until age 14 and then decreases after that. See, this is information we can see from this frequency chart that we really couldn't see when the data was just all scrambled around and sort of raw data. So that's a benefit of doing a frequency distribution. So how do we do a frequency distribution, frequency chart? Well, we start with the statistics, 40 students, and these are some test scores. What we want to do is we want to group them, the frequencies, into classes that are meaningful for the data. So you might want to, what they're going to suggest, I'll just click it, is that letter grades are generally every 10, 90 to 100's an A, 80 to 90, so forth. So here's your A, this would be a B, a C, a D, and again, anywhere down here is your F. So I don't know why we need to go there, but when you do a frequency chart, though, we have to group them by the same amount. So at least that's kind of the rule. So here's what we want to do is we want to make a class. So the class will make 40 to 49. And then how do we get the frequency? Well, we just come through here. Here's a 47, so we put a marker. And we go down, 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 and we just look through. It's kind of tedious, but you just kind of, there's a 45, and there's a 43. Hey, it's all in a row. I don't see any 40s, so we'll say there's 3 there. That's its frequency. Then we're supposed to do 50 to 59. And again, we just go through. Here's 59. Here's a 50, 57. So I got 1, 2, 56. There's 1, 2, 3. 1, 2, 3. So a total of 6. 60 to 69. Let me just go ahead and do these. We're going to do 70 to 79, 80 to 89, 90 to 99. There weren't any hundreds. We could, kind of look at so 60 to 69 is our next group. Here's 1, 2, 3, 4, 5, 6. So I don't need to do the tallies. I could just kind of keep them track in my mind. Just depends on how you want to do it. Multiple ways, 70 to 79. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wow, that's kind of cool. Just make sure nobody interrupts you while you're counting, right? You hate that. 80 to 89. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. It's good. That's we want people up in the higher. And then we could just count the 90s or so. There's 1, 2, 3, 4, 5. 5. Okay, so that's what I got there. Just tedious. You could make mistakes. Again, you could miss ones and such, but that's because there's computer programs that will do this too, which is nice, especially if you have a very large amount of data. But that's a frequency chart, and again, now we can take a look at that. We got a lot of 70s. Maybe these are your C's, B's, and A's. Let you know how the class did, and then oftentimes we'll put something like n equals 40. That tells us the size of the sample. And that's always a good way to do your frequencies is when you're done, add them together. Make sure you got your 40, got all of them, 5, 9, 11, 6. Okay, so let's see, did I get that right? Let's go back. 5, 9, 11, 6, 6, 3. 6, 6, there. We got them all. Okay, so you'll be asked in the homework, I believe, to make a frequency chart. That's how you go about doing it. Okay. Another thing you can do, this is from the data from the maximum growth year for boys. Looks like I need to do an adjustment to my, there we go, to the lights, and I'll get this set up again. I'm trying to use two studios at the same time, and so I've got my lighting going back and forth. But anyway, hopefully you can enjoy this. The main thing is you can see the PowerPoint pretty well. Okay, so one way is another way instead of the frequency table is to do a histogram. Okay, so then we've got the 10-year-old. There was one that was their maximum growth. Basically, that then after that they grew most slowly. 11-year-old there was 2, 12 there was 5. So we've got this bar chart or what we call a histogram because they're right next to each other. And notice the nice labeling here. We've got this that tells us what this is. This is yearly growth frequency. So this is the frequency. Sometimes we'll see percentages on this side. Down here we have nice labels of what this is. This is the ages of the when the maximum growth was, and so it gives us a nice visual. The other type of display that is used is called a frequency polygon. I don't like these as much because they're a little bit misleading, but they do get used. And what they basically do is they take this histogram, they put points in the middle, and then connect them with a line. Now, the part of this is some people will come and say, oh, this line has value, so this one in the middle means at 11 and a half years. No, that doesn't. The only data points that really have any meaning are the ones here at the middle. So it can be, but it also helps to see the trend, overall trend. But I can see it with the histogram itself. So again, my money's on the histogram. Give me a histogram. I don't really like these, but you may see them used. Okay, stem and leaf plots, another way to display data. This one's kind of cool. It's like the frequency table, but it's made up of the data itself. So here's, I think that's maybe the same data we had for the test scores. It might be different data. I didn't memorize it, but if we do a stem and leaf, here's what we do. Instead of putting a class like from 40 to 49, what we do is we put, well, 40, right, has a 4. So the 4, 5, 6, 7, 8, 9. These are the tens values. And then what we do is the leaves is we come along here. Here's a 47, so I put a 7. And then I keep looking. Any more in the 40s? Make sure I don't skip. Here's a 43. So I put the 3 there and the 5 there. So it gives the information that there's 3 in the 40s, but it gives a little bit more, not just that there's 3 in this group of 10 numbers, but I can see there's a 147, 143, and 145. So I've also got access to the actual data. And you'll see as you go through this, the 50s, you kind of come along, and you're putting the ones digits here, 54. And the ordering's not critical. However, if I were going to do a final product, I would probably put them in order. It kind of helps. 57, so I just put the 7 part. 50, I just put the 0 part. And 59, I put the 9 part. Okay, so I can see 1, 2, 3, 4, 5, 6. Now, I probably should have put these smaller, but because remember the 70s has 11 numbers. But we'll do one more. It's kind of tedious. 64, I put my 4 here. 63, I put the 3 here. And 68, I'm going to put the 8 there. And you should, think ahead and try to keep them at about the same. So there's 4 should be about that. They should all line up. Um, Mine's a little sloppy, so they're not. Here's the 6 should be out there. Okay, so that's all the 60s. And then again, if I follow this, my 7s are going to go off the page. So they're just going to explain how to, your stem is your tens digits, right? Right, like here. Your units digits go over here. Uh, and they give you sort of this histogram look too, you know. So you get your histogram, you get to actually look and see the data. Uh, and again, I've seen some where they'll take it and they'll organize the leaves by the number values. They'll put them in order from smallest to largest, and that's even nicer, easier to look at the data. Okay. So now we get into this last few slides, which is going to be deceptions. And this is the part that hopefully you take with you. It's not so much we're going to test you on this and such, but this is the part that applies to real life. So here's some deceptions that can occur. So the graph in both figures represent these data. So here's the data, the year, the rate of poverty. So notice this makes it look like it's really going up. Over here, this looks like there's not that much change. Well, which one's correct? Technically, they're both correct, but notice what they've done. Over here, on the, well, I guess that's the left-hand side, they've used, they sort of use smaller units, so 11.3, 11. So it's going up by 0.4, right? And so that's going to sort of stretch out the data. It's going to make it look more. Notice it doesn't start at 0 either. So that's another out. That's another. We're zooming in on something, which is going to make it can make a small difference look large. Here they've done the same thing. They're only showing the top, but then look at this. Each tick mark is 2%. So that's going to reduce the look of any differences. And when you look at, let's see, what is this for? Percentage of people in the United States, that's a large body of data. You know, 0.1% is probably quite a few people. Yeah, I don't know if we have 300 million people or more. Look up the stats. So this is more along what's going on. You know, this is giving us it's a problem. Is going up, even a slight change. Here, just it just went up a little bit, but hey, that's 11.7 all the way to 12.6. That's 12.7 here. That's a whole percentage increase. That's a lot of people. Okay, so you can read all of this, but that's basically what's going on. That's my explanation. Is look at your vertical rate. So it can be done both to make something look like a bigger problem than it is, or to show the problem at the scale it is, that it really is a big issue, or it can minimize something, or so. And again, one other way is if we would have started at 0, this would look even less of a difference. So what are the things you watch for? So look for titles. Do they explain what's being graphed? Because otherwise you're jumping to a conclusion to have to say this means this and that. If they don't label it or title it, they may be hiding something from you. Look at the numbers. Are they lined up with tick marks on the vertical axis? Do they clearly indicate the scale of what it means, the units and such? Do they vary it? Is it maybe more spread out or less spread out on one or the other? And then are they kind of using a lot of design and cosmetic effects to make it, fancy? We'll take a look at one of those, and it might actually distort the data. And then finally, has it given some sort of wrong impression, or maybe just an emotional impression itself, when we just really want to be able to make a data-informed decision, and not be swayed one way or the other. We just want to know the facts, just the facts. Okay, so do we give a wrong impression? Are they equally spaced intervals on the horizontal axis, and those kind of things. So here's another example. I guess that's next. Our bar size is scaled up proportionally in terms. So sometimes that's another thing they do is they make the bars sort of different sizes. And is there a source? Do they say where it's coming from? Who got this data? Remember that one about the casinos and the hotels said, "Hey, let's do it this way at the nightclubs." If they were the ones that sponsored that study, hotels sponsoring a study about whether to bring a casino that's going to make their business go well, we're going to question it. At least we should. Regardless of how you feel about guns, if a survey or a study was done on whether there should be more gun, what do they call that, regulation or not. If one group does it, say the National Rifle Association, they did it, that's suspect. If the other group, there's a John Birch Society, there's I can't remember who it is, but there's another society that really doesn't want guns at all. If they did it, it's suspect. Maybe we want someone in the middle, maybe a neutral source doing some of these studies. So look for the source. Then how much do you know? Was it a random sample? Was it truly a random sample? Does everyone in the population have a chance to be in the data? All of these kind of things are things you'd want to consider. We'll get a little bit more into this as we go through the actual calculations and statistics. Okay, and this will be our last one. So we see this one, and again, you can read through here, but number of square feet in an average U.S. single-family house. So notice one of the things they point out is first, when they do this, this is a case where they're giving us a graphic that can be a little misleading. Notice the house sizes themselves are changing. This one has a garage. These guys don't. And then what I think the graph itself is really is kind of, if you just go to the top of the peak there, that is on par. But notice they've also got a two-dimensional thing where this one is much wider than this one. So it kind of actually doubles what it gives this impression that it's twice as much more. The other thing is down here, this is 10 years, and then this is 20 years. So we went 10 years, and then we jumped 20 years. But you see three houses there, and you kind of get the impression that it's equal time amounts. So, the faces are different, and then also they're using the width, which is going to influence. And really what they're trying to measure is if you had the scale over here, it would be the tip, which is good, but maybe just a histogram, maybe just a bar chart, maybe just a frequency table. I don't know. But there's some deceptions here. Okay, so it looks like greater increases from 1980 through 90, averaging 34 square feet per year, then 90 through 2010, averaging, this many square feet per year. So this was actually the greatest increase in square feet per year, at least. But it certainly seems like going from here to here was the greatest. So anyway, watch for those. Don't be duped. Make sure you're following through on these. So this gives us a nice firm foundation. We have some vocabulary we understand. We know we're going to practice doing a few frequency tables. What else? Maybe some stem and leaf and some histograms. Being able to read them, construct them. And then what we'll look at in our next unit, our next two sections that we're going to take a look at is finding the middle of the data, mean, median, mode, and then also the spread of the data. And there's two ways we can do each of these. So the mean has a way that's typed with it that's called the standard deviation. So we'll look at doing that as a calculation. And then the median, which is the actual physical middle, that has a 5-number summary. So we look at quartiles and those kind of things. So if you've heard of those, great. If not, we're going to talk about them. um, in the next unit. So take a look at the homework, come back with any questions. Let's keep making this good progress, and let me know if you have questions. Thanks.